Welcome back to Summarize Science. Operating rooms are some of the most complex and high-stakes environments on Earth. Every movement is critical, which makes it incredibly difficult to train new AI-powered robots for surgery. You can't just let a learning robot practice during a live operation, so how can we make them smarter safely? This is where a groundbreaking new concept called TwinOR comes in. Researchers have developed a way to create an ultra-realistic, dynamic digital twin of a real operating room. Think of it like the most advanced video game level ever, but it's a perfect copy of a real place. They start by doing a detailed 3D scan of the room and all the major equipment, creating a static foundation. But an operating room isn't static, it's full of motion. This is the brilliant part. They use multiple cameras to capture the movements of the surgical team and equipment during an entire procedure. As you can see here, the system tracks everything, from the surgeon's positions to the movement of an X-ray machine. This live data is then fed into the digital twin, creating a breathing, dynamic replica of the real event. The level of detail is incredible, achieving what they call photorealistic visual fidelity and centimeter-level geometric accuracy. The goal is to make the simulation so convincing that an AI can't tell the difference. So, does it work? To find out, the researchers ran tests that are crucial for any robot that needs to see and move around. They tested stereo depth perception, which is how an AI judges distance, and the results were impressively accurate, down to the sub-centimeter level. This proves the simulation is visually realistic enough for an AI to understand the geometry of the room. In another test, they put a virtual humanoid robot inside the digital twin and tasked it with navigating around the busy environment. The robot was able to successfully track its own position and movement using its virtual cameras, just like it would in the real world. This is a huge deal because it shows that AI systems can be trained and validated in TwinOR for complex tasks like navigation and interaction. So, let's recap the important points. The TwinOR framework creates a safe, controllable, and incredibly realistic virtual operating room. It captures not just the look of the room, but the dynamic movements of a real surgical workflow. This effectively closes the reality gap that often plagues simulations, making them too simple or unrealistic for real-world training. What does this mean for the future? This technology could dramatically speed up the development of intelligent surgical assistants. Imagine robots that can anticipate a surgeon's needs, pass the right tool, or navigate in or without getting in the way. By providing a risk-free playground for AI, TwinOR is a major stepping stone towards a future where humans and robots collaborate more safely and effectively in the operating room. Thanks for watching Summarize Science.